Today's lab is going to involve some organic chemistry, and it would be a good illustration. Both of them are going to involve silicic acid, this molecule right here. One of them, this one right here, is going to be making an ester out of this by not adding it here, but adding down here, over here. So you're going to be taking this OH group here, and you're going to be adding this acetic anhydride to form the ester on this alcohol group, this hydroxyl group here, as well as then acetic acid. Okay, so read through this very carefully, and you'll see how you can do it, how one would accomplish this. This is the first part. And for this experiment, they give you how much of the silicic acid that you would be using, how much of the acetic anhydride you'd be using, and there's an excess of this. And for the amount of aspirin that you will produce, had you been doing this, 1.95 grams. 1.95 grams is what your actual amount of aspirin that you would come from this reaction as it is carried out. That's not the theoretical you. So theoretically, you should be able to get a bit more than that. And what you'll do is you will go through these calculations to find out exactly what that would be. And read through the directions of how this experiment would be carried out and learn about those. Another one of the things that is involved in this particular lab is this test down here. The result of the ferric chloride test on aspirin, the result of the ferric chloride test on the salicylic acid. Now, the idea of the ferric chloride test on any compound is it determines the presence of a phenol. And this is a substitutive phenol here, right? You've got a benzene ring with an OH on it. So the presence of this group right here means that there's a color change when you add ferric chloride solution to that material. And what you would do is you would take something about 0.1%, okay, in a water solution of this material and of this material, these two materials, and then to that you would add a few milliliters of a ferric chloride solution. And if you get a color change in the material, what that indicates is the presence of this material right here. So you should have it on the salicylic acid. You should not have it on the aspirin. Okay, so that's the first one. So here what we're doing is we're adding an ester group down here, replacing the hydrogen here with carbonyl and a methyl group, right? So that's what we're doing there. In the next lab, okay, this involves two different things I'd like you to look at. Here what you're doing is instead of replacing this H right here with an ester, what you're doing is the more common, taking the H of a carboxylic acid and reacting it with an alcohol, and then this portion of the alcohol replaces that hydrogen right there, and you get water out as well, right? So anyway, these right here also include the technique of vacuum distillation or distillation under reduced pressure. And the reason why you do that is because that greatly lowers the boiling point. So if you have a lower pressure, and they show you how you go about attaching this sort of a thing, how you are taking your action is taking place here, and then what you are doing is you are cooling things down right here so that you would end up getting your solid material there. Your temperature is recorded at this particular portion right here, And what you're doing is you have this sort of accessory for vacuum distillation to ensure that you are able to get that reduced pressure, so you lower that temperature of boiling. And this talks about all of that and the boiling point of methyl salicylate. Okay, and methyl salicylate is another name for oil of wintergreen. So here you are doing another esterification of salicylic acid. What you're doing is you're replacing it up here. In this particular one, you start off with 6.9 grams of salicylic acid. You have an excess of the methanol, quite a bit of an excess of the methanol. And then you are forming the addition right up here of this methyl group in place of this hydrogen. Now for the actual yield right here, for the amount of material, I would use 6.5 grams. 6.5 grams here, and you'll notice you have acid here as well as the alcohol group here as well. So use 6.5 grams here. You'll have to calculate the molecular weights. You'll have to do the number of moles, make certain you have a balanced equation. That's where the equivalents come in. And then what you're going to be doing is calculating out the theoretical yield, the actual yield, and then the percent yield. Okay? So your actual yield is the number that I gave you there. That is the 6.5 grams. Okay? So you should be able to calculate all of that. But the idea here is just to show you how with different materials, we can very specifically change this hydrogen and make an ester in this case, or in the prior case, we replaced this one with a different type of compound in different conditions so that we had an ester formed down here. Okay, so that's organic chemistry can be very, very precise. You have to know exactly what sort of conditions and how you can carry them out and what will allow you to have something take place at this place versus this place. And sometimes this will just give you a little taste for what you can actually accomplish here. I hope you enjoy this, and I hope it's educational for you. And gosh, I wish we could have done this in the lab. But be that as it may, you will only need to turn in these this page right here, as well as this page right here. Okay, so those two report pages are the two that you will need to turn in to me for the lab report. Of course, include your name and everything else, as they have up there, and as well as the date. Sorry, no partners, and sorry we can't do this in person. But anyway, let me know how it all goes, and if you've got any questions, let me know.